when I go through this problem, I'm trying to solve for x, y, and z. The first thing you got to do is you got to get rid of a variable. I want to pick a variable with a 1 coefficient. So in this case, we could get rid of the y's or the x's. I'm going to happen to get rid of the x's here. If you got rid of the y's, that would work just as well too. So if I want to get rid of the x's, that means I'm going to rewrite the top equation along with that bottom equation where x has a 1 coefficient. And then I'm going to go to the bottom two equations. 2x minus 3y plus 3z equals negative 1. X plus 4y minus 2z equals negative 1. So essentially, okay, I've got to get rid of the same variable 2 times. So whatever equation has a 1 coefficient with a variable, that's the one we want to write twice. And we just match the other 2 up with that bottom one. It doesn't have to be the bottom one. If I was getting rid of the y's, I'd match the top 2 and then the top and bottom. Okay? But since I'm getting rid of the x's, I match top and bottom and the bottom 2. That allows me to do less work. So now I'm going to multiply negative 3 by the bottom. And I'm rewriting 3x plus y plus 2z equals a negative 5. And underneath, negative 3x minus 12y plus 6z equals 3. When I combine, my x's cancel, and I'm left with negative 11y plus 8z equals negative 2. That's going to be one of my 2 variable systems of equations. While this is not the answer, it's an important piece of information to get to the answer. So I've eliminated that x. I'm going to eliminate the x here as well. I'm going to multiply everything by negative 2. So 2x minus 3y plus 3z equals negative 1. Copy that top one. Negative 2x minus 8y plus 4z equals 2. And I cannot stress enough how important it is to be careful with your signs. The x's cancel again. I'm left with negative 11y plus 7z equals 1. And while, once again, that is not an answer, it's invaluable to getting to the answer. Because now I've created an Algebra 1 problem. Now I have a systems of equations. This one's pretty basic. I'm just going to multiply the bottom one by negative 1. Negative 11y plus 8z equals a negative 2. 11y minus 7z equals a negative 1. When I combine these two, the y's cancel. 8z and negative 7z is z. Negative 2 and negative 1 is negative 3. That's my answer for z. You plug back in negative 11y plus 8 times negative 3 equals a negative 2. Negative 11y minus 24 equals negative 2. We add 24 to both sides. Negative 11y equals 22. Divide by negative 11, divided by negative 11, y equals a negative 2. And then we go back to an original. I would do the x plus 4y minus 2z. X plus 4 times negative 2 minus 2 times z. So x plus 4 times negative 2 minus 2 times negative 3 equals a negative 1. X minus 8 plus 6 equals negative 1. X minus 2 equals negative 1. X equals 1. So my answer is going to be 1, negative 2, negative 3. That's the answer kind of written all together. I'm going to say X is baseballs. Y is basketballs, and Z is a soccer ball. Now, a lot of times I would have said like B and S, but B's, I have two B's, that's why I'm going to use X, Y, and Z. So in this case, on Monday, we sold 4 baseballs, 3 basketballs, and a soccer ball. 4 baseballs, 3 basketballs, and a soccer ball. And my store made $31. On Tuesday, we sold 3 baseballs, 2 basketballs, and 2 soccer balls. We made a total of $25. On Wednesday, it was 1 baseball, 2 basketballs, 4 soccer balls, and on this day, we made $19. Notice, I do not write the dollar sign in there. All that does is clog up your problem. Now I need to make a good decision. What variable am I going to get rid of? The choices here are X or Z. Since I got rid of X in the first one, I'm going to get rid of Z in this one. With that being said, could you get rid of X? Absolutely. So, I'm going to get rid of Z though. So I'm going to write 4X plus 3Y plus Z equals 31. And below it, 3X plus 2Y plus 2Z equals 25. And then I'm going to write 4X plus 3Y plus Z equals 31. And X plus 2Y plus 4Z equals 19. And by doing this, once again, I only need to multiply one thing to an equation. I don't need to multiply by both equations. So if I'm getting rid of the Z, I have a 2Z on the bottom here. I need to multiply by a negative 2Z here. So negative 8X minus 6Y minus 2Z equals a negative 62. And I recopy 3X plus 2Y plus 2Z equals 25. Negative 8X and 3X is negative 5X. Negative 6Y plus 4Y is negative 4Y. The Z's cancel. Negative 62 and 25, okay, is a negative 37. If you can't do that in your head, everyone has an option to a calculator. Use it. Now I have to get rid of the Z here. I can't get rid of the X. Once you choose to get rid of Z, that's what we're getting rid of. I'm going to multiply the top by negative 4. Negative 16X minus 12Y minus 4Z. And 31 times 4 is 124, so it's a negative 124. On the bottom, we're left with X plus 2Y plus 4Z equals 19. Negative 15X minus 10Y. The Z's cancel, and we're left with negative 105. Okay. 124 minus 19 is a negative 105. Now, that gives me my 2 equations I need to complete this problem. Now I'm dealing with a system that only has 2 variables. I should know what to do here. It was an Algebra 2 problem. Now it's an Algebra 1 problem. I'm going to multiply the top here by negative 5. I'm sorry, I misspoke. By negative 3. Excuse me. So now my x's will cancel. I'll be left with 15x plus 12y, and 37 times 3 is 121. And it's a positive 121. Nope, it is 111. 37 times 3 is 111, yeah. Negative times a negative is a positive. Negative 15x minus 10y equals a negative 105. So when I combine here, I get 2y equals 6. And my y equals 3. So I believe basketballs will cost me $3. Negative 5x minus 4 times 3 equals a negative 37. Negative 5x minus 12 equals negative 37. We add 12 to both sides, and we get negative 25. Divide both sides by negative 5, my x equals 5. And then I'll go back to an original one. X plus 2y plus 4z equals 19. So my x is 5. Y 2 times 3 plus 4z equals 19. Now 5 and 6, that's 11 plus 4z equals 19. 4z equals 8, and my z equals 2. So my answer is going to be a baseball, $5. A basketball, $3. And a soccer ball, $2. And that is so 3 numbers. I'm going to make x the first number, y is the second number, z is the third number. The sum of them, x plus y plus z equals 38. The sum of the first two, x plus y, is 6 more than the third. So if I take 6 away, that would give me the third number. The sum of the first two minus 6 gets me to the third. Because the sum of the first two is 6 more than the third. So the sum of the first two minus 6 will give me that third number. The first number is 2 less than the third number. Okay? So the first number is 2 less than the third number, z minus 2. I'm going to use those top two equations first. X plus y plus z equals 38. And I'm going to manipulate x plus y minus 6 equals z. I'm going to get the x, y, and z's all on one side, and I'm going to get the numbers all on one side. So if I subtract z to the other side, it'll go. If I add 6 to the other side, it'll go. So it becomes x plus y minus z equals 6. And what works out nicely here is this. When I combine these, 2x plus 2y, okay, the z's cancel and we're left with 44. So yeah, so I made a mistake when I made this problem. It should be 2 less than the second number. So this is going to be equals y minus 2. And now the change is this. 2 times y minus 2 plus 2y equals 44. And now I've created a one variable equation. So 2y minus 4 plus 2y equals 44. 4y minus 4 equals 44. 4y equals 48. My y equals 12. Which means then, okay, my x would equal 12 minus 2, so my x equals 10. And then 10 plus 12 plus z equals 30. I believe it's 30. So 22 plus z equals 38. Subtract 22, we get 16. And 12 and 10 is 22. That's 6 more than the third number. And my 3 numbers all work out.